Hey guys, so welcome back. So what we got here is a Sencore Super Mack. This is a what is it, a CR31A CRT tester. I picked this up at a swap meet, I think it was, many years back. For older sets, I've been using an ICO 625 with a picture tube adapter, which is okay for 12 LP4s and things like that. But I found this and thought maybe I might be able to use this for a newer machine. So I picked this up. It's missing some parts in terms of adapters. It's also got a piece that's been removed and needs to be replaced. So let's open this thing up and take a look at what we got, and we'll see if we can get this thing returned to service. So let's get started on that. Okay. So we've got high voltage probe. We've got a number of the adapters. Adapter 1 is missing. I know I have a source for that. Some of the other ones are missing as well. Now, the person who had this had a scheme for how to make a universal, and I may do that as well. I found a thing online, a guide online by a guy named John Young, and he shows how to make your own adapters in here. And so this looks like something I'm going to be able to utilize to maybe, instead of trying to use this to make a specific adapter, maybe what I would do is use it to make a universal by going to the different points that you would use on a picture tube, right? So I may do that later, but not necessarily at this point. But the main thing you needed this Amphenol socket. Well, like I said, the guy who had this in here, and that's what this is. That is the right size socket that matches up to the cord that's on the tester. So I can plug that in. Unfortunately, when they cut all these leads, they're too short, but I can use this to create a universal adapter, come out and have some pigtails with some clamps or grabbers or something, and I may do that later. But this would be for basically being able to use this tester for many other applications than just the ones I have these adapters for. Alright, so what's missing on this is the filament set knob is missing. Knob, I should say, the potentiometer's out of there. The other things I have in here is I've got, what is this? Replacement leads price list. I don't have the shop manual for this. I have the setup book. As far as the manual goes on this, I sent a note to Sencore, and I asked very nicely if they could perhaps send me a PDF on this. And they responded very quickly, and I will say very nicely, declining. They said they just don't have it. They didn't have the information anymore. But they did respond very quickly, and I really appreciated that. So thanks, Sencore, for that. Hope you can find it someday. But anyway, and we got something here for us having tube guarantees for, I guess, rejuvenating it. Alright, so in here, let's see what we got. We've got the probe, I guess works with this. We've got this, and then we've got the remains, it looks like, of the control that was in there. One of the things I was looking for in the manual was to find out what is the size of this potentiometer. I'm not exactly sure. There is a track that runs around the inside here, so you can see it. Come on, focus. Oh, I can focus, but you can't see it. It's like a wire wound. It goes all the way around here. And so I'm thinking maybe what I can do is just go in here and just check resistance from one end. You can see it's burned up. But maybe go from one end to the other, or maybe halfway across, assuming it's a linear taper, and get an idea for what this total resistance was for this potentiometer. And I'm going to guess it's probably 3 to 5 watts. So let me test this. I think I did some searches on these numbers and was not able to get anything that helped me. I think I would, but I wasn't able to find it. So anyway, I'm going to try to test as far as I can on that winding to see if I can get a guess. I'm hoping it's like 1,000 ohms. So let me do that real quick and we'll see what we can find out. Okay, let's see if we can deduce what the characteristics are of this. And maybe you could see it a little bit better now. Maybe. So you see it's kind of burned up in that spot right there. I'm just kind of pushing this little bit of wire out of the way. And so the idea is let's see if we can get an idea of what we think the total value of this potentiometer was. So what we're going to do is go from here. And then what we'll do is we'll go to, let's look at halfway. So we got continuity. Yep. No? Yep. Looking here. Okay, so halfway would be right around in here. So let's touch halfway. 330. Come over here. 460. 500. Okay. So when I was doing some research on this, I had a couple of options to what I thought this was. One of the other testers I was able to find the manual for online had this as a 1K, I think it was 3 watt or 5 watt, I don't remember which, potentiometer. There was another source I had that said 700, and I don't remember what it was because it's been a while since I did this, but I put an order in and I've got a couple of 1K. So we got a couple of 1K, and is this it? Yeah, 700 ohm. So let's see, it looks like the 700 ohm is our winner. This is a 5 watt. So let's see, we'll go from here to full scale. Yeah, there's 700, I said watt, 700 ohm. And this is a 5 watt. So let's see, if I set this wiper midway, let's see, so there to there. Okay, so midway is about right here. Let's just see what we get midway. 330. There we go. I'm going to say that that was a 700. Okay, and of course what I'll do is I'll test this into a load and we'll see what we're getting in terms of the filament to see if I'm able to get the right range that we're going to have here. And I have 1,000 if I want to put it in. But it looks like to me this is going to be the right size. So this is a, let me get the right paperwork here, hang on. Okay, I think this is it. This is from the data sheet. So this is the part number. And then this is 700 ohms, linear curve, and it's a 5 watt. So I think we're going to be in good shape. I think the one that was in there was 3 watts, so we picked it up a little bit. Okay, now will it fit? It won't quite go in all the way. I might be able to thread that in, but I probably just need to open that hole up a little bit. And then the last part was the knobs. I went into Mauser. I took some measurements of this. This has been, I don't remember when I did this. It's been several months. Those are pots. Hang on a sec. It's been several months since I did this. Here we go. Yeah, it's the right size. And I think I got a pretty good match. Yeah, that's a real good match. But what I did is just to make sure they matched, I bought 3. So I'll just maybe replace all 3 of those and then they'll match. Alright, I have never had this opened up. We'll open up the inside and we'll see what we have in here and see if we can put that in and see if there's any other damage that might have happened inside that might have caused this to fail in the first place. And then failing that, we'll see if we can get this thing up and see if it'll perform. So the bag that had the remains of the potentiometer in there also had a set of screws, so I guess I hadn't even realized that this thing was just loose in the case, and I just lifted it straight out. The screws going to the top and I guess on the bottom. Alright, I have not turned this around. Let's see what we got. Okay. We have got a disconnected connector. Why, I wonder? Maybe just to get access to the control. Let's see, here is, okay, we're going to have to find out where these wires are coming from and going. I see a green wire, I see a white wire, and I see two wires. Hang on a minute. My difficulty is I don't know exactly which one went to what terminal of the potentiometer. Maybe I could look at the way it wants to be, the way it wants to lie. Okay, we've got a cut resistor here. I'll get you where you can see. We're doing a little bit of detective work here, I guess. So let's see. We've got a cut resistor here, and we've got a white wire with a purple stripe and a green wire here. Yeah, I don't know if I can tell from that which goes where. That is really tight. Is that wire just a loop? That wire's just a loop. Okay, I'm going to have to figure out the reason of what goes where. I'm going to use that other schematic from that other unit to see if I can get a clue from functionality what it is. I know that it's, I believe that the wiper is in line with the resistor, and because what it's doing is basically adjusting that resistor. And that looks like 150K, and yeah, this one here goes to, looks like it goes to this switch, which is the bias. And the green one, I can't tell where the green one goes. I may have to take some things apart to get in there. Oh, it goes up here to life test. Well, that would make sense. Okay, well, let me put this back on before I destroy the needle, and we'll see if we can figure out what wire goes where on that potentiometer. Okay, so I just got the dial cover just stuck back on with some tape for right now. If I get the thing working, I'm going to take advantage of it being loose to clean it off some, and then I'll refix it better. Okay, so what we're doing is we're trying to understand what these wires were that were going to the potentiometer that we're trying to replace. So let me go in there and take a look at it. So one of the things I've learned is I was wrong about the resistor going to the wiper. So I found this schematic online. This is for the Big Mack, which I think is very similar to the Super Mack in that, except it doesn't have a rejuvenation or beam builder, they call it, feature. But I was using this kind of as a clue as what we have. And here's our missing potentiometer. And here you can say for this one it shows it's a 1K 5 watt. We just measured 700 ohms for the potentiometer we had, but it was burned up. I wonder if maybe somebody replaced it with a 700 and it didn't work. I don't know. But I've got both. So what I'm going to do is wire it up outside just using jumpers and see how it behaves. And I should be able to determine whether the 700 will work, or I've got 1Ks. I can use that. Both of them are 5 watts, so it'll be fine. So yes, what we got here is, I wasn't reading my orange and my yellow properly. It was orange, not yellow. So it's a 15K resistor in there, not a 150K. And what it is that the resistor is not on the wiper. The resistor is helping this form a voltage divider, which is what this potentiometer is moving. And here you can see that the lead that comes off the wiper goes to that life test that we were talking about, which is that green wire, we think. I see a green wire going to life test, and I see a green wire that's cut off, but it goes behind a bunch of other components. So I need to verify whether that's actually the same green wire or not. If it is, then I may just cut the existing wire short or pull it through and reroute it to make it a little bit easier to get to. So we may do that. So in order to test that, what we're going to do is I'm going to use continuity. So let's see if you can see what I want to do. So the green wire in question, so this, let me back up, this wire right here is the one that goes to this switch here. Sorry, goes up here. So this is the white wire with the purple stripe. It goes to one end of the potentiometer. This end here goes to the bottom of the potentiometer here. Sorry, here. And now we just need to verify that I have the green wire going to, or at least a wire going from the wiper to the life test. And I think it's that green wire that we see cut. So the green wire we see cut is right in here. And I don't know if you can even see that. I don't have much to work with here. I'm not going to be able to strip that very easily and make a good connection. So what I've done is that I've looked for where I think that went. And you see I've got a test lead on here to remind me. There's a switch right down in here. That is the back side of the life test. And so what I want to do is verify that that green wire that I see there, get you where you can see, hang on. There's a green wire right in here. I'm going to try to attach to that same post that it's on and verify we've got continuity. And if it stays with continuity when I operate the switch, then that'll tell me I'm on the right wire. Let's see if I can get that in there. Okay, I'm on it. All right, so let's see this lead here. I'm going to connect up to my ohmmeter if I can. Come on. And go to beep mode. All right, now I've got the red lead connected with this jumper. Okay, so that is continuity to that lead in there. Alright, so we want to verify is whether that green wire right down in there on the end of my hemostats is the same one. Now the insulation has been cut and I can't really strip it, so what I'm going to do is let me see. I'm going to use an X-Acto knife that has a very sharp edge on it. I'm going to clip the lead on that. Okay, and I'm going to go in here and see if I can poke it right to the end inside of that insulation. Okay, there we go. So we're verifying that that is the same wire. So what I can do is, rather than trying to strip and go into this lead right here, what I'm going to try to do is just, I need to verify it still works with if it's buttons pushed. Hang on just 1 second. So you go here. Come on. Come on, beep. Okay, let me operate the switch. Yeah, let's operate the switch. It's still beeping, so that's good. Okay. So what I think I'm going to do is back you up just a little bit. What I'm going to try to do is pull this green wire around and just pull it out through here, and then I'll make an extension to it and then just bring it around to here and wire it up, rather than trying to pull it back through, or rather than trying to strip this and then solder it and get some heat shrink on there and not have a solder blob drop somewhere. So I'm going to do that way. And then what I'll do is I'll hook up the potentiometer, and that way we'll be able to see if it operates properly, whether we can get the thing to work at all, and then also whether I've got the ends, wired correctly, so that when I turn the filament adjust up, then the filament voltage goes up and not vice versa. And then once I get that figured out, then I'll worry about mounting it. But then the other thing I'm going to wonder is, why did it fail in the first place? So we'll see. I may just need to check the plug and then put a load on it and see if it works. So Let me look at pulling this wire through and then rigging this thing up for a test on the end of jumper leads. Okay, so I've got the potentiometer here, and I've got the wiper hooked to the resistor inside here. I've got the white lead connected to that end, and I've got the green end connected to the far end. So let's see, have I got that wrong? Yes, I had that wrong. Start over. Okay, so I've got the units temporarily wired in to see if the potentiometer is going to work. So I've got it wired in here. I've got the white lead going to the white connection here. That goes up to this selector switch here. The green lead runs off of the wiper and runs off to the green lead that we have soldered, attached to pigtail 4. And the far lead I've got connected with a red wire that goes to the resistor, which is what we have here. Okay, so what I'm going to do is I got to plug this back in. It doesn't look like it's polarized, but it don't. Gosh, how do I know it's right? I don't know. Did they twist it? Well, I'm assuming that's right. I'm going to have to go with it. I don't know the way to check it, but it looks like it wants to go that way. So we'll try it. Is there any way to verify polarity? Hang on, let me see if I can figure out polarity, make sure I got it right. I don't think I have a way to check it, so I'm just going to go. It looks like it naturally wants to go that way, so we'll just run with it. And we'll see how it goes. See if we get the 6.3 volts on the right leads, because that's what goes to the plug on the outside, so that'll be our clue, I guess. Alright, so let me get this set up. Make sure everybody is okay in there. And we'll roll this around where we can see it from the other side and see if we're getting any life out of this thing. I've never had this plugged in, so we don't know yet. Okay. So let me back you up and we will fire this thing up for the first time since I've had it. Okay. So what I'm going to do is I'm going to bring it up on a I have a dim bulb and I have a variac over here on the right. Let me get you where you can see what I'm doing. And I'm going to bring the voltage up slow and just make sure we don't have any shorts going on. So I'm going to get some of my housekeeping dealt with here. Get some of this out of the way. Let's go. Voltage is down. I'm not using the fluke right now. I'll see the voltage coming up on this. Plug it in. I'm going to be watching the current back here just in case I have a problem. But I've got a 1 amp fuse and I've got other things going on. I've got a dim bulb that is in the circuit. I think I've got a 60 watt bulb in there right now. Okay, so it's plugged in. We want to set this on. I'm going to line volts first, I guess. And then let's just see what we get. Just going to put voltage to it and see if we have anything bad happen. So you can see the voltage is coming up. Let's see. This is not an on-off switch. So power on. Okay, I didn't see anything happen. $60 volts. Let's see, we're in line volts. Okay, let's see if our switch is dead. No, something's happening. The needle's moving. All right. Okay, so we're in line voltage. This light is lit up. I don't know if you can see that, but that light is lit. See it? Okay, so there's 90 volts. Here's the line check right here. 95. You just let it sit there for a little bit. I don't know how long this has been since it's been used, and let's just watch what it does. I'm not going to hurry this. I'll bring you back in a few minutes. I'm just going to let it sit there for a bit. You know, it looks like to me somebody's pried their way into this plug. Took this apart and pried this cap off. I hope they didn't mess around with the wires in here, like maybe they were looking for a short, or maybe they created a short. I don't know. We're going to see what we can get here. I'm going to wait to see if this will settle down. So we may have some capacitors charging, I guess. So let's see. I see filament set here. I know I'm not up to operating voltage yet. I'm still not getting any current to speak of. There's 110 volts. I'm not reading that here. I don't know, maybe I'm not using that right. I think I am. I'm reading 110 here, and here I'm reading a little under 110. I don't see an adjustment for that on the front. So there's 120 volts. I'm moving a little bit of current. I'm probably, I don't know, maybe about 100 milliamps. I don't see anything bad happening. I'm going to turn the voltage down, and then I'm going to bypass the bulb, and just so we can see how this is tracking. Here you go, bypassing now. Let's see if we get any difference. So there's 110. $120. Yeah, it's not coming up to here. I'm not sure what's going on there. Let's just switch over to. I'll tell you what. I'll put the bulb back in before I switch anything. Okay, bulb's back in. Let's go to filament set. Filament set, and I'm turning this. I'm not getting anything happening. Okay. Potentiometer is not warm. Not moving very much current. I'm not getting anything happening here. So I may have something else burned out somewhere. We'll have to see. I want to go back to line volts and let it sit there for a bit. Okay, now our line voltage is up high. The bulb, okay, I'll turn the voltage down. I have the bulb in the circuit, still not moving much voltage. I mean, much current, or any current really. Those capacitors, I don't know what's going on. I'm going to leave it at 120. The bulb is in the circuit. This is reading high. Let me drop it to 0 and see if that needs to be adjusted here. And just turn it off. Okay, let's give that an adjustment. Okay. Shouldn't be turning it that much. Let's see what's happening here. Okay. You know the needle will move. Doesn't seem to be responding to this though. The needle mechanism may be damaged. Let's see. Okay, I'm watching the needle just move around. I've been in here messing to see. There's a hairspring that's attached to this. That's kind of like on a balance on a watch, and the hairspring is attached to the arm that comes off the top of this fork that you have here. There's an arm that goes in and it's got a hook on it, and you can see a little solder blob on it, and the hairspring is attached to that still, so it isn't broken off. I can move this around, and you see this is moving around a bit. The power is off, and it's kind of moving around, so I don't know what's going on with this right now. I'm going to let it settle down, and then I'm going to look inside and see if I can see anything weird going on. I'm also going to look to see if when we get around to it, how I would put a test on this. I think I might be able to use our test plug here to get in there and access pins 1 and 11, which on either side of the index, which is what normally would go to the filament. So yeah, I could kind of do this and then try to connect up to those pins one way or another. I'm not sure I'm going to do it. Anyway, I'm going to give that some thought, and I'll be back. Okay, so I've been keeping an eye on this. You can see it's still moving around. I don't know if it's doing it as much as it was. This meter is damaged somehow, I think, and I think somebody's had it out. There's some looseness. There's a screw here that's loose. It won't tighten. I put some double stick tape in here to try to get the gauge cover, the meter faceplate to stay where it was, but it's still kind of moving around. This fork that's down there, this leg was bent backwards. I think because somebody had been trying to put the cover back on with the adjustment post in the wrong location and forced it and bent that piece back. I've tried to pull that back into position, but I still can't really get this to where it's supposed to be. So my concern is that this meter is kind of on its way out. Now it is doing something, which is good. If I change the voltage here, you'll see it is sort of responding. Now there may be some capacitor drainage that has to take place, I'm not sure, but it is doing something here. So I'm going to take that as a good sign that maybe there's something we can do with it, or maybe there's something else going on inside of here. So you see it's still moving around. So I thought what I would do is just to quickly determine how much of this might be related to the meter versus... Okay, I had to change my camera card. So as I was saying, I think what I'm thinking about doing in terms of trying to isolate how much of what we're seeing here is related to the meter being weird versus something going on inside of here. I thought what I would do is put a substitute meter in here. Now this one says here that it is 100 microamps DC full scale. I don't have one of those handy, but I do have in my stash this guy. And this one is full scale 200 microamps DC. So I thought I would take this one, disconnect the leads going to this, and just plumb this in and see if it behaves the same way, and just see if I'm getting anything that looks kind of like it would make any kind of sense. The other thing I could do if I want to go further is I could put one of my meters in line with this and read it digitally and see how many microamps we're getting. And I should be able to go in here and say, look, if this is full scale 100 microamps, I should be able to go back in and figure out what some of these different points are as far as this goes. I might even be able to find it out of the manual of the Big Mac, which I have, as opposed to the Super Mac. But anyway, I thought I'd maybe try this. Now, having said that, I have done some looking around at what was going on, and I went back to make sure that as I was moving things around, I hadn't messed up how I had these connected in the back. And as I was doing that, I was looking at that resistor that had been cut, and I looked at it, and it looks like it's been really hot. Okay, so there'd been a short that had burned up that potentiometer. It may have burned up that resistor or put some heat stress on it, and I thought I saw another resistor in the power supply that looked like it had been hot. So I'm not going to mess around with this too much. We must have a problem with the power supply, and that may be what's causing this wandering around. We may have a voltage regulation issue. It may not have anything to do with this setting. It might be even in the rejuvenation circuit. I don't know. But I'm going to take a look at that. But real quick, because it's not hard to do, I'm going to disconnect one of the leads going to this and then use some jumpers to connect it up to this, and we'll just see if this thing wanders around the same as this. And then we'll get into looking at that power supply issue I was talking about. So let me get this plugged in and we'll take a look. Okay, looks okay, so let's turn this around. And we'll see what this one does down here. It's 200 microamps full scale, so it's not going to go as far as this one, but it'll be interesting just to see. Alright, so power back on, and let's hit the switch and see what we got. Look at that. This is going to 200 microamps right off. Makes me wonder about this. But anyway, let me try moving the voltage around. That all looks pretty normal, doesn't it? It's not wandering around. You know, it's not seeking, is it? No, it's pretty stable. This was wandering around more than this one. Just also to kind of keep track of what the situation was before I did anything else. I hooked up a test piece, this plug that we were talking about, to the outlet. I went through with a couple of leads and soldered them into the pin sockets. I've got a couple of test leads hooked up to those leads there that come out of the test socket. And then I've got those running over to a 5 ohm power resistor to put a load on the filament circuit. And this resistor is getting warm. It's hot, in fact. That is a 10 watt 5.1 ohm resistor. I've got this set at 6 volts for the filament right here. We're not really seeing anything here. If I switch that to line volts, you see it still comes up, and I'm getting the 200, microamps. But if I go to filament set, I don't get any reading from this per se. But if I put a voltmeter across the power resistor, then I'm seeing that getting closer to 6 volts. So if I take our adjustment, which is getting warm, by the way, I can turn that and get up to about 6.3 volts. So that part is kind of working, but I don't like how warm everything is getting. So I'm going to shut this down and we're going to go take a look at the back. Okay, let me show you what I found. So here's where we were pulling into this resistor that was cut for removing the burned up potentiometer. You might see that it's looking a little blistered. I've checked the resistance on that. It's about double what it shows. So I'm going to look at replacing that resistor, but I don't think we found it all, because if you look up here, here's the power supply board. Okay, you can see the filter capacitors, and if you see that resistor right there, it looks like it's been cooked. Okay, what is that? 8200 gray, red, red. So I'm going to see if I've got an 8200, and that looks like it's a watt. And but we'll check what it is. I'm probably going to need to pull it out of the circuit to see what it is. But I did some poking around. Let me show you what I found. So since this is the power supply board, let me bring this in. We're going to check the rectifiers. So I'm going to put this in diode mode here. We've got CR01 right here. Okay. I don't see another one right there, but there's a CR02 and a CR03. The 03 looks smaller than the 02, so I'm going to think that the two rectifiers are here. So let me test those. So I'm going to put red to the cathode and black to the anode, which has the stripe, which should beep. And then we've got about a half a volt. You can't see. You're not watching. Hang on. Can you see it now? Okay. So I go here. Okay, that reads good for a silicon diode. Let me reverse these. and this should be like an open circuit. And it is. Okay. So far that diode checks okay. So let's check CRO2. So I'm going to hook it up backwards like we have before. I'm going to have the red on the anode. There's a bar, there's a line there. I put this one on the cathode, so this should be open circuit. Okay, I'm getting nothing. Now let me reverse the leads, put red on the anode and black on the cathode, and it should beep and then give us like a few volt, portions of a volt. Okay, so 0.51 volts, that's good. Okay, now let's go to CR103, which is right next to it right here. Okay, so I'm going to have, I see the cathodes at the top, so I've got my red lead here. I'll put it on the bottom, so that's on the anode. Let's see. And then I'll put the black on the cathode, so this should give me like 0.5. Okay, see if I can get it. That reads as a short. So let me reverse the leads. Black on the anode, red on the cathode. That's a short. That diode is shorted. Okay, that could possibly be what's causing a lot of these issues. There may be some cascading issues that came from that, like overstressed resistors, burned up potentiometers. Who knows? That diode's got to go. All right. So as best I can see, I'm going to have to pull it out to verify it, but I'm pretty sure. I mean, it's going to be a short. It's a short, right? I'm going to pull it out to see what it is. I think it looks like a 1N4760, which is a Zener. It's a 63 volt Zener. So I don't see how that would have anything to do with the filament side, but who knows. So it has to do with voltage regulation, so it could be messing up our meter and so forth. So having said all that, I know I want to take that diode out. So basically I need to get this board out. So in order to do that, I got a couple of screws to get out down here. I'm going to have to disconnect some of these connectors because I don't want to go in there and risk having solder blobs fall down below. So I'm going to go ahead and pull this out, and then I'm going to check what else we have in here to see if anything else has been damaged or is shorted as well. I don't have any more. I'm fresh out of 63 volt Zeners, if that's what that is. So I'm going to have to place an order if that's what it is. But I'm going to take this board out, and we'll take a look at how everything else seems to be checking out. I'm going to take some pictures so I know how the Molex connectors were throughout this thing, and we're gonna get this thing out. So I'll bring you back after I get it out. When I change those resistors, this variable here may need to be adjusted. I'm going to get a source of the manual, hopefully, for this, so I'll know how to check the settings for all this to see if that's everything I need to get out. Okay. Looks like we're hung on something down below. It's just a wire that's in the way. Hang on a minute. Okay. This board is out. So here you can get kind of a better look at this resistor I was talking about that looks kind of roasted. We've got like a daughter board on here that connects to the gun switches on top. That looks like that is soldered in place. It looks like I'd have to break the solder connections here to get this off if I need to get access down below. I don't know that I do, though. No, there's nothing really on the other side, so I don't think I need to mess with that. Okay, I don't know what all this black stuff is they put on here. Alright, we will check out the components we've got here. I'll check these pots out since I have them out, and see what we got. But there's not a whole lot to check here, is there? There aren't any more diodes than the one I saw. I was expecting to see a bunch more. There's another board down here. Let me show you this. There's another board down here, and when I was pulling these plugs loose, I noticed there's a screw missing here. So I don't know, but it makes me concerned. This board's been out. There's a number of, looks like Zehners on here. I'll see if I can check some of these. That's a new resistor right there, I think. Anyway, I'll go see if I can get in here and check what I can check, and then see what we find. Okay, let me don't get too off target. I'm gonna check these things out, and I'll let you know what I found out. Be right back. Okay, let's do a quick check of what we got. We got resistors in circuit, so if they're higher, that's not a good sign, but if they're lower, it's probably just because they're in parallel with something else. So we'll start on this side. Get the glasses on. We got 3.1, so that's a 310,000. Yeah, that's in, let's see, 3.1 and 4. Yeah, 310,000. It's probably something in parallel with it. Let's try this next one. Let's check this big one. It is 8.2's 8200. This is the one that looks like it's been warm, huh? It's about 10K. It might have been damaged. I don't know if it'll prevent us from getting a test, but since it's out, since I've got it out, I may go ahead and change it, right? Because that's supposed to be 8,200 and we're at 10,000. So we're a little bit out, especially with a gold band, I mean a silver band on it. So we'll change that one. That's not too far off. Okay, this next one says 25K. It's a precision. Get in here to it. 25K. How's that? 25K looks nice. All right, this next one is a, what is that? Brown, black, orange. 10K. Okay, here we go. 10K looks good. And I think it's this last one. This is another 10. Brown, black, black. Okay, there's a 10. So I'm going to take the opportunity to change this one out. There might have been another one here. I'll double check it, but I'll lift the lead before I change too many of them. But I may go ahead and change that. 8,200. Let's see, 8,200, 10%. It's going to be about 9,000, right? And I'm a little over that. I'm about 1,000 over that. So I might go ahead and change this guy. It's just I'm going to maybe need to figure out how to adjust this. All right, so I may just leave it for now. Let's take a quick check of the capacitors. We've got, we're going to check just the ESR. So these are 10 microfarad, 315 volt. So 10 at 315, it should be no more than, what is that, 6 ohms? Yeah, it should be 6 ohms or less. So here's 0, 6 ohms is over here somewhere. Okay, so let's try this one. That's good. That's 0.75. And let's try this one here. We're just checking ESR here. That's not the whole story. We don't really checking capacitance or leakage, but if these kinds are showing good ESR, they're probably okay. So that's also 0.75. So those both look fine. Okay. Okay. So now if I go to the one right next to it, that's my suspected one that's bad. Yeah, it's just short. If I reverse it, just make sure I didn't make the basic mistake. Yeah, it's short both ways. Okay, so let me get that diode out. We'll get it identified and we'll see what it is for sure, but I think I know what it is. Okay, so at least here's one of our troublemakers. So one in, 4760A. 1N4760A. That's a Zener. And yeah, I'm fresh out of those. I'm going to have to order this. Meanwhile, what I'm going to do is go ahead and hang on a minute. Yeah, so before I place an order, I'm going to go ahead and probably lift the lead on a couple of these just to make sure there's not something wrong with them. The way this one was kind of drifting around is weird. It kind of reminded me of the way the meter was behaving. So I'm going to lift this one and check it. I don't know what could be wrong with it. Everything else on here seems to test okay. I'm going to test these others by lifting leads just to be sure. I'll replace this. Everything else in this board's okay. And while I've got this to where I can get to it, I may just check a few things in here, just see if I see anything that looks like it's gotten hot, or I'll check the diodes and see if any of those have shorted. And then we'll get our order in and we'll get these things on the way. And then we'll see what we got. Hopefully I can dig up a manual by then so I'll know how to reset everything. Okay, so I got some parts that I went through and lifted a leg on and checked them. And I decided that I'm going to change these items here in addition to that Zener that was down in here. Then I think I'm also just going to go ahead and replace these capacitors. They check okay on ESR, but you know, I'm here, so why not do them? They're not expensive. Everything else on here seems okay. I haven't checked the pots. I probably should do that. I'll hook them up with a meter and see if I can get some kind of reading on them just to see if they move smoothly, make sure there's no dead spots on them. Okay, now on the other board that I was just talking about, I went through and checked this out, and it has some problems too. There is a dead Zener here. That one's no good. This one, this resistor, is burned beyond recognition. I believe it to be a 68 ohm. It measures over a meg. So I think this has been pretty well roasted. Yeah, it's a blue, I think it's a blue-gray, black. So I think that's a 68. I'm going to replace that, obviously. This capacitor is shot. It's open. So I've got it pulled. It's not fully open. I think it was 8 or 9 ohms. So that needs to be replaced. Everything else on here, I checked the rest of the Zeners and the resistors. They all seem to be just fine, including these, including this. This is a coil. You see the L number, L201. So I believe that'll be a coil of some kind. I'm not going to bother with that. Lest I haven't tested any of these transistors. I'm just going to assume they're okay. One of these is a flip-flop. The other one's like a quad NOR. I'm not going to mess with those. But basically I'm going to replace a resistor, a Zener, and a capacitor. Now, I went and ordered some parts for this, and while I was waiting, this is a couple of days later, on this item, it's got a switch on the front for switching between CRT circuit tester and beam builder. So I thought while I had the parts out, you know, this is a good time to check out the rest of the chassis, see how the rest of it is, you know, is everything else moving like it's supposed to. I need to put some cleaner in the switches and so forth. This wouldn't move. And it wasn't like it was stiff to move. It wouldn't move. So I thought, well, this is a good time. Let's get this thing out and take a look at it. I found something really surprising. I'd be interested to know if any of you guys have seen this before. Now, I've picked at it some. Let me zoom you in so you can see what I'm going to talk about here. I've picked at it some, so it's not exactly the way it was when I found it, but I'll show you, or I'll try to explain to you what it was. Let me put something white behind this so you can see it. Okay, so here's the switch. Let's see if I can get this where you can see it. Hang on. Okay, can you see it pretty well? Yeah. So here's the switch that sticks through, and then down below it there's another switch. So it's two switches that are ganged together. And it has a pivot point, or a fulcrum here, if you will. And so when you move this one shifts this way, or this way, then it pivots that point and it makes this shift like this, right? It wouldn't move. Now you can see maybe why. Look at this little hairpin. This clip, I pulled it out, but this tail of this clip was stuck down through that hole, and it was locking this. This would not shift to the beam builder side. It would not shift to do any kind of rejuvenation or restoration on this thing. I think it's factory. It's such a well-made little hair clip. I got one end out, and this was like frozen because I don't think it ever really been exercised since maybe it was new. I treated it with some contact cleaner, and I've got it now where it'll kind of work. There we go. It'll work now. I still have half that hairpin kind of engaged. What the heck? Do you think that maybe companies ordered these but said we don't want people to mess around with rejuvenation, and they asked Sencore to defeat the switch? I mean, that looks factory to me. I don't know. I'm going to have to approach the rejuvenation side with a bit of trepidation because I don't know if it's ever been worked or if it even works. Maybe since this was going to be defeated, maybe that whole side of the thing hasn't even been checked. I don't know. If I get a manual in, and I'll definitely go through and check all this. I don't intend to do any rejuvenation on anything anyway, but I thought that was really unexpected. It looks like it's got a factory delete on there, or disable. I don't think somebody just added that. Anyway, I've got it disconnected now, and we'll see what we do with that later. But meanwhile, I'm going to probably leave this in just the testing function, and I'll worry about that later. Hopefully I get some documentation where I can check this out before I finally basically just want to put it all back together. Anyway, so like I said, it's been a couple of days. I've got my parts in that I need to replace all these elements that we've been talking about here on the boards. So I'm going to get busy on that. On this guy here, which is the capacitor used for trying to eliminate shorts and things like that, I ordered the wrong part. I may just leave it, or maybe I'll put it on a capacitor tester and see if it'll reform. It's a 450 volt cap. Maybe I'll just do that and see if it's willing to reform, but it's not a priority. All right, so I will put this all back together again, and then hopefully I can get some information on how to reset all the variable resistors and so forth, and we'll get going on it. Another thing I noticed is that on the transformer down here, way down in here, there appears to be a ceramic capacitor. I'm assuming that's a line filter cap, and I don't know if you can see it, but it's split. Can you see that? Yeah, it's got a split in it. I'm assuming that is a line capacitor for noise. I'm thinking about pulling this transformer out now that I'm at this stage and seeing what that is and maybe replacing it. And I can put in the appropriate safety capacitor. The other thing I noticed is this unit has no fuse on it. We've burned out some resistors and diodes and all that kind of stuff. So I'm thinking about installing a fuse inside. This is the lead that goes to the power switch, and I verified that it connects to the hot lead on the plug. So I think what I might do is interrupt this line and install a line fuse inside of here. We'll see what we do. But anyway, I'm going to go ahead and start working on the circuit boards and getting those items replaced. Not hyperextending anything. Okay, that capacitor is not attached to the transformer, and it goes between chassis ground and, what am I feeling here? Oh, that's the external plug. That's interesting. It says RMC 1-2 kV. Yeah, it goes from the neutral to chassis ground. So I'm going to call that a filter capacitor. And I think I've got an X1Y2 I'm going to put in there. I don't think that'll hurt anything. That's obviously just being used as a filter. Okay, I'll see if I can get in there and replace that guy. I don't like him. There's a better look at him. Yeah, so it goes from the white line. I'll verify that's neutral. I'm sure it is. And it goes down here to chassis ground, so that's a filter. Well, I cut this little guy out of here and pulled it out where I could see it, and my jaw dropped open. When was the last time you saw one of these? It's a spark gap. It's not split, it's cut on purpose, or it's separated on purpose. That's a spark gap, and it's supposed to go at like 1 to 2 kV, I guess, or 1.2 kV. I don't know if they're that accurate. But anyway, that is a spark gap. That's for like lightning arresting. I did not expect to see this. I was so excited about putting a safety cap in there, I didn't think that I would have a spark gap buried down in there. So the question I have is, do I need to have this? Because I got this big discharge capacity, capacitor thing possible. I wouldn't think it would get back out to this point. I don't know if I should put this back in. I mean, there's not anything wrong with it. I could still put a safety capacitor bypassing this. I might do that, but boy, I sure cut the leads short, didn't I? Anyway, spark gap. When was the last time you saw one of those in modern electronics? I haven't seen it in a long time. Anyway, there you go. Okay, so I got the parts installed, and got the spark gap put back in, and I got these all set to go, and I got there's those new capacitors here. I think they look nice. Got the new Zener right in there, and replaced a few other resistors. Put this one, I put a 3 watt in here and put it up off the board too. So that one should be good to go. I put some cleaner in the pots. I haven't yet put a meter on them to see how they sweep, but I think they're probably okay. We'll just see how they go. This one I've done the same, and it's interesting. I did get the schematic and so forth in for this, and interesting. I'm glad that I did. Okay, so first of all, I said this is a coil because it's an L201. It's actually a relay, so that's pretty cool. I didn't expect to see that. All right, and nice thing about the manuals explains how to zero and set everything. This has to do with the timer on how long a rejuve goes and how long the gap is between the next cycle. This one is for zeroing, I forget, was it the gun balance? I'm not sure about that. Don't quote me on that. And this one is for the line adjust. So the way this works is that, according to the manual, is that when you go on a service call, it could be that the house has poor line voltage, and that the television might not be performing well because the line voltage is not where it's supposed to be. So the idea is that you plug this into the wall, and then you plug the TV that you're there to service into this point right here. And then you read what the line voltage says. And what that does is it allows the load of the television to then load down the circuit, and then you can read what the voltage is as a result of that, and you can find out if maybe the service in the house is inadequate for running the television, and that's actually the problem. So that's what the problem is there. Problem I have is I was also thinking about putting the fuse in. So if I put the fuse where I was planning on putting it, it would have to be able to handle the load of a TV going through here as well. So I may just leave it like it is, or at least leave it like it was designed. I may change my mind. We'll see how that goes later. But that's how the line voltage works. You set here, it's not meant to be adjustment on the outside like you would on like a tube tester, but this is set at the factory. And so we'll be able to do that ourselves when if we can get a working meter. We use that to tune in what that should be. And it will affect, I think, how the whole thing reads elsewhere as well. So it's good to get that resolved. Now, one of the things that I wanted to point out is that on this board here, I've got a resistor here and I'm going to tell you this is temporary, okay? And this is the one that had been burned up on this board. Let me see if you can see that. I have to stand up so you can see this. Hold on. Okay. So I'm talking about R217, okay? And I've got a 1/4 watt in there right now. My schematic is missing a page of parts. So I don't know exactly what that is supposed to be. I'm going to set this thing up, and I'm going to put a voltage reading over that to find out how much current is going through that, and then I'll know whether I need to get a larger resistor. I probably do. But I want to show you something. So this is the resistor that was there. That was burned up. Now, let's look at this, and let's decide what do we think the colors are there. I see a gold band. Okay, that's tolerance down at the bottom. And at the top, I see blue, so that's 6. And I've been saying that below that, I'm going to say that it was probably originally gray, so that's a 6/8, right? And then behind that, I think I see black. So this is a 68 ohm resistor. Now let me show you what it shows in the schematic. So first of all, if I go to the board where that was, that's resistor R217. So then we're going to go to the schematic and find R217. All right, R217. Do you see it? .8K. So the 6 and the 8 are right, but that wouldn't have been a black band, right? That would have been an orange band, right? 6, 8, no, red. 6800, right? So it should be blue, gray, red, right? This isn't blue, gray, red. I don't think it ever was. So this is the first time that I thought I wasn't the first one in here. I think somebody changed this, or the schematic's wrong. But that's a 68, not a 6.8K. So I've got another resistor in there. I'll measure voltage across it. Like I said, my parts list is missing that particular page apparently. But I'll follow the schematic, and we'll go with that. Okay, so the other thing I did was I went ahead and got that hairpin off of here, and the switch seems to work just fine. So I'm going to put it back in, but I'm going to leave it pretty much in just the testing mode until I have a chance to really go through and check that other part of the circuit. But I must say I'm a little bit impatient to try to get the rest of this put together to see if I've got some other, problem, with something else, for example. And so just see if I can get back to have some kind of basic functionality, and then I can start troubleshooting it. So I'm going to try to put most of this back together again, and we'll start to just run through some of the basics to see how it wants to behave. And so I'm going to start putting all this back in. Okay, so I got the boards put back in, I got the knobs put back on the front except for the gun balance. I'll put those on in just a minute. But I got the boards put back in, and I'm about ready to try to go back and repeat the initial startup test. I've got that one resistor. I need to watch its power requirement right here. I'll put a meter on it. I've left the potentiometer out for now like I did before, so I could see how this size works for adjusting the filament. Now I was doing tests earlier, but so many other things were wrong in here that I'm sure that might have thrown off everything. So the schematic that goes for this shows that that's a 700 ohm 5 watt, and that's what I've got in there right now. So we're going to put that in to give it our first try. We'll see how it turns out. I don't have the meter connected up completely. I've just got some jumpers for it because I may find the meter still doesn't work and I need to substitute that other meter. But anyway, I'm ready to pick this thing up and start to do another test, and we'll just see how we do and see if this made much difference. Like I say, I think the meter is probably not going to be perfect. It's got another problem. But anyway, I think this is all set up okay. Make sure I don't have any shorts. Yeah, this is all looking all right. Okay, and I'll get this secured. All right, so now I just need to put the knobs onto the gun balance, and then we'll get the test started. Okay, we're ready to give this a shot just to see where we stand on this. So I've got the switch set into the CRT circuit tester. I'm probably just going to leave it there. Let's see, my filament adjust potentiometer is here. Let's get this around where we can see it, although I'm not planning on messing with it right now. I've plugged into the line volt here with a cheater cord, and then I've got it connected to my fluke so that I can make some measurements. So what this suggests in the manual is that you bring this up to a voltage of 115 volts, which puts you right precisely mid-scale on here. And then you can adjust that adjustable potentiometer on the power supply board I was showing you and dial it in. I want to do this to make sure I'm at 115. But we're just going to see if this thing overheats or whatever. I'm going to turn the filament voltage all the way down. I'll turn everything down. I'll go ahead and turn the power on, and I'm ready to now come back here and turn this on. So bulb is in the circuit because I've been doing some stuff to it. So let's go. Okay, I'm right at 120 volts going in. Light up. I'm not drawing hardly any current. It's good to see. All right, let's go to volts here. We didn't get anything on the meter. Okay. Okay, we're not getting anything happening to the meter. All right, so we're going to start going through this and see if we can find out what happened. Well, yep, I forgot to plug one thing in. This is main supply power going to the board here. All right, let's go back and do that test. I think it's probably work a little better now. Power's off, turn the voltage up. Okay, I'm still going through the bulb. I've got it set at 120 volts out of the variac. And we're passing through 120 volts. Okay, so let's switch it on. So that's already coming through. Okay, so we got meter response. Turn that off. Turn it back on. Okay, we got meter response. Okay, great. Let me zero the meter. What I'm going to do, well, that looks zero. What I'm going to do is, let me just see if it responds. Okay, let me turn this down to 115, which is how you adjust this, right? I was going to make a comment that when this is off, notice the output voltage. Now, of course, it changes because this is pulling down the voltage because I'm going through a dim bulb, okay? And when I get rid of that, I probably won't see that happen. But my main thing I'm noticing is that the voltage passes through to here without going through the power switch. That means I can put a fuse on the power switch potentially. We'll see if we end up doing that because it may, I don't know how it'll behave with everything else. But I'd be really interested in doing that. But meanwhile, the power just passes straight through even when this is off. So anyway, power back on. See, off, on. All right. So I think what I'm going to do, let me just see if it responds. So there's an adjustment back here on the power supply board down here that adjusts the meter for what's going through. You want to adjust the meter to read 115 volts, which is at mid-scale of that big meter. So for calibration, what they say is set this for 115. Okay, it's close enough. And then set the meter for half scale here. Now, I don't have a way to do that here per se, but what I'm going to do is I'm going to hook up another meter here. Let's see, how can I do this? I need to put this in series, don't I? To where this reads 100. No, this needs to read 50 microamps. So let me rewire that up. Just give me a minute. So at 115 volts going through this unit, the meter is seeing 38.5 microamps. Okay, see that? DC microamps. So what I'm going to do is reach back here. I'm going to grip that knob. on that resistor, and I'm just going to turn it. And we'd like this to read 50 microamps when that is reading 115. Okay, so I'm reaching down here to that knob we were just looking at. Let's see if it'll respond. Okay, here we go. We want it to say 50. Getting close. 50. Now, I'm not going to get too tweaky with it because I think I'm going to let this thing kind of stabilize. Okay, what I'm going to do is let this set and stabilize for, I don't know, 20 minutes or so, and before I go back and really check this. But I am kind of eager to check one more thing. So we know we're at 50 on that. Let's see. So what I'd like to do now, let me just disconnect this for now. Alright, so the other thing I want to do is I want to check the filament supply. So I'm going to use this to check the filament supply. So I've got this, which we've wired up for pins 1 and 11, if you will, which are the filament, or heaters I should be saying, heaters for the CRT. I did this test earlier, but I just grabbed a power resistor I had handy, which was a 5 ohm, and it was reading low after I plugged it in. Well, 5 ohms not enough resistance, so it was pulling everything down. I pulled up the data sheet on one of these. So I pulled up this information sheet, and it was 6.3 volts, and it was 600 milliamps. So if you just do a little bit of Ohm's law on that, then it's looking for an operating heater resistance of 10.5 ohms. So this is the resistance that's within the tube. So that tells me how much I should put as a load resistor. So there was a project I did not too long ago where I replaced a selenium rectifier, and I needed a 10 ohm resistor, and I went ahead and grabbed a 5 watt. Bought several 5 watts just so I'd have them around. Now I'm glad I had one. So I'm going to hook this up against the filament and see how we're doing on that, on the voltage. Okay, so let's see. I need to take this. I'll get myself wired up here. This one will go from here. Okay, so all of this rigmarole was to show that I've got the plug adapter plugged in. I've got the 2 heater lines going to this 10 ohm resistor, 5 watt power resistor, and I'm wired up to measure the voltage across the resistor, and this will be AC volts here. Alright, so now I'm ready to turn this on. I got the filament voltage set at 6, and let's see what we get here. Okay, switch this to filament set. This jumps up, but let's just see. Are we doing okay here? So that. Okay, let me get this out of the way. We don't need this for right now. So I'm getting response on the meter for different filament settings. Let's see what's going on. I've still got this set for microamps. You guys never had that problem, did you? Okay, so there's 6. Like here, 6.6 going into a load. So let me turn the filament adjust. And I'm turning it up, which is the right sense. And we're getting there. Come on, baby, don't run out of room. Looky there. Can I go even further? I can. I can go up higher. That's fine. I just didn't want to be at the end of the throw. Okay, so I'll go down to 6.3. I like it. All right. So what do we got? Well, we got the filament voltage is working. This is working, the line voltage is working. Like I said, I'm going to let this warm up for a while before I finally get that calibrated. It's probably pretty close though. And then I'll go through and check a few other things. But that's good news. We'll figure out what we're going to do about this. Like I say, I may want to take it apart and take a look at it. But as it is right now, we're getting somewhere. Okay, it's been about 20 minutes, and I think this thing is stabilized just fine. I mean, I can sit here and tweak around, but 115.54 volts going through here, and you know, this is supposed to be 50. I mean, when you're looking at a scale like this or like this, that's close enough. I mean, I could go in here and tweak this, but I just don't think it's really necessary. Silly trying to move the variac this little amount. Okay, that's close enough. This is close enough. All right, and this is reading correctly too, right? This is a 200. I put this on because I think some wind in the room was blowing the needle around. I have a fan going over there. So this is supposed to be reading halfway on a 100 microamp scale. This is a 200 microamp scale, so it's reading 2.5, which is exactly what you want. Okay, I think that we're done with checking the line voltage and checking the filament, at least for the 6.3. And I think now what I can do is I think I can go in there and make a zero adjust on, I think it's the HK shorts setting. I'll do that. Let me get some other things set up and we'll see how we're doing. But I'm thinking about going ahead and putting this filament adjust in. I guess I should go ahead and do that. I'll do that first. Okay guys, I'm going to stop this video right here as the end of part 1. We've still got a ways to go on this, but we've made a lot of progress. We went through and tried to find out what had somebody been trying to deal with. We know that they had a burned up potentiometer. They'd had it out of the case. And we found that there was a failed diode that had failed as a short, and that may have caused the whole problem. And there may have been some cascading failures as well as a result of that. We know that the previous person had at least the main board out and perhaps had changed some components. I don't think they found the problem. You know, it looked like they had even partly disassembled the external connector that would go to the CRT adapter plug, perhaps looking for a short there. But we think we found the part. It was very helpful to get the schematic. I was able to find that online. I bought it, and we got the right diode put in, and we got this thing to basically function. We've got a few more problems to go, so I'm going to cut this one off yet. But I'll tell you, this is a really challenging project. This item has not yet begun to fight, as they say, and I have not yet begun to finish the mistakes I'm going to make. So hope you find this interesting. We're going to carry on next in part 2 when we get to it. And I appreciate you guys watching, and comments are always nice to see. So I'll see you next time. Thanks.